Ladies and gentlemen, good afternoon. This is Imad Bintaw. I'm Associate Professor at Hikma School of Engineering in Jeddah. The title of my presentation is Aligning Engineering Education with Industrial Needs through Specialized Courses. The agenda for my presentation is as follows. So I will introduce the context of this work. After that, I will describe and go through the related works, basically the works related to the development of cornerstone courses, followed by a description of the engineering design course, GE 211. After that, I'll go into the course assessment results, and I will conclude with the conclusion. I will also, at the end of the presentation, show you a video that shows the artifact that has been done in this design course. Okay. So the engineers are one of the important work, I would say, in our life. So they are dealing with really solving complex issues that has direct impact on our daily life. Think of it that the engineers have to construct bridges, they have to construct airplanes, they have to construct electronic systems that can help us to connect remotely, etc. So this engineering is really important and vital, and it is affected by a lot of factors. One of them is the progress in technologies. So in the engineers, they have to work in an environment and in industrial settings, and then he will work in solving problems that falls into one of the five categories: chaotic problems, complex, complicated, simple, and disordered. For that, the engineer's education has to fulfill all the skills needed by the work by the workplace. Also, if we look at the trends in engineering courses and engineering programs, there are new driving force. And currently, there are three driving forces. The first one is employability, and here can be solved by collaboration between industry and academic programs to reduce the gap. It can be, for instance, using internship, learning labs, and challenge-based learning. It is also motivated by the UN Sustainable Development Goal, and there are 17 of them. I have listed few, like no poverty, zero hunger, good health and well-being, quality education, gender equality, clean water and sanitation, etc. And the last point is Industry 4.0, and this is the fourth revolution, which is sometimes referred as industrial IoT, the technology for that. So the Industry 4.0 requires interdisciplinary skills in computer science, data analytics, robotics, automation, production, management, electronics, and materials. Now, those are the motivating factor. And also, if you look at the skills demanded by the fourth industrial revolution, so the engineers should have skills in data management, flexibility, lifelong learning, critical thinking, entrepreneurship. So, which means that all the engineering programs should their program learning outcomes cover these five domains. And remember that in the international communities, each country has what we call NQF, National Qualification Framework, and most of this framework really cover the needs for the fourth industrial revolution. Okay, so coming to the related works, so related works because of the gap that exists between the skills given by the academic programs and the skills needed in the workplace. So people come up with, and the university come up with different ways of reducing the gap. One of them is using the cornerstone courses. So here the cornerstone courses have been established to foster innovation, creativity, teamwork, and to increase rotation rate among freshman students. I will start from 2018, and I'm sure there are plenty of them, but I just summarized the most important. So Long conceived a cornerstone course that promotes skills and innovation, engineering design, and teamwork. Again, here he did not really consider the new trends like UN Sustainable Development Goals plus the fourth industrial revolution. In 2019, Genovic devised two cornerstone courses for some of our students. So the first was intention or goal was to increase rotation rate by having an engineering-oriented course, just to motivate the student to continue their studies, and also to develop skills in design, teamwork, communication, and project management. In 2020, Ritter and others have also described a cornerstone course offered by at Pennsylvania State University. This course aimed at giving skills that address the sustainability issues defined by the UN Sustainability Goal. I think this work is very much close to what we have done at Qasim University. Okay, so for the our course, so the engineering design course, this is course. It is required also by the IBAT accreditation. So the course we cover the 5 steps in solving the problems, what we call creative problem solving process. So we start by problem definition, solution generation, course of action decision, implementation, and evaluation. So this course, it is active learning, and it is given in 2 alternating weeks, 1 week for one week for the labs, and 1 week for the concept. Okay, so the course learning outcomes, there are 17 of them, and you can see that from the course learning outcomes, it really covers what is needed from the UN sustainability goals, and also with what is required from the fourth industrial revolution, or Industry 4.0. So the CLO number 1 is to develop and exhibit the behavior associated with taking personal responsibility for time management, classroom expectation, professional ethical behavior in the class, and academic integrity. Practice elements of active learning, and again, this will lead to lifelong learning skills. Explain quality customer expectation and process, as well as demonstrate the ability to meet customer expectation. Again, this will also stimulate a bit the market and the work at the industrial side. Develop team norms. So here we are adding here skills related to the team working. Use effective team tools such as team agenda, minutes, and team process check, as well as team dynamics tools such as maintenance phase. Use team discussion tools such as the Bogle method, affinity process, deployment flowchart, multi-voting, and prioritization techniques. Explain problem solving strategies such as using heuristics, perceiving problems, potential problems, real problems, etc. Explain problem definition techniques such as exploring the problem, present state, desired state, Dank diagram, statement. So I will not go all these details for the CLOs, but you can see that the CLO are well crafted, so that it can meet what is requirement from the new engineering skills. Okay, so as I explained, so the course is given into 2 alternative weeks. The concept week we cover it's run over 7 weeks. So he has only mentioned 6, but the 7th is basically for doing some activities. So in week number 1, so they meet 3 days, 3 days per week. Usually it is the first day of the week, and then the 2nd and 3rd day of the week. So if week number 1, it will be covered the course introduction to active learning, and then there is a video about the misconception, a private university video. In week number 2, it is about engineering disciplines, presentation of technical work, introduction to engineering ethics. Week number 3, paradigm and heuristics, discovering the future video, problem solving, creating solution, brainstorming, and Bogle method. Week number 4, so day number 1, generating solution, day number 2, deciding the course of action, KT decision analysis, and then constructing a KT decision analysis table. In week number 5, so the first day is about KT situation analysis, and here we are taking the live problem, which is by Exxon Valdez problems. And K2 potential problem analysis, a solar car example. And in day number 3, implementing the solution. And here they go through the critical path scheduling and precedence diagram, which is techniques used in project management. And in week number 6, so they have to evaluate the solution, ethical and social implications, including also sustainability stuff, reverse engineering and assessing of work product. Okay, so for the course assessment, so the course are done to measure cognitive behavior and affective behavior. And also just to remind that this course is also, it's about discipline. So the student learn to come in time and also be active member within their team. So affective behavior is also very, very important. So here for the assignment, so they have, students have to work in teams in the assignment during the concept week and also during also the lab, engineering the profession, active learning, problem definition using present state, desired state, generation solution using brainstorming techniques, Osborne checklist, random stimulation, Kaplan-Treuger or KT decision analysis, KT situation analysis, KT potential problem analysis, Gantt chart, applied ethics, reverse engineering, teammate interview, preparing design notebook, team dynamics, jigsaw exercise, and this is part of the active learning, promoters and barriers to team performance, and team norm generation. Now, when it comes to grading, this course follows the industrial standard. And remember, if somebody would like to rate a product, it will use exceed expectation, meet expectation, needs improvement, non-credible effort, or non-submitter. Okay, so here are for the quiz grading. So here quiz either with journal or without journals. So the quiz usually is about 10 questions, and this 10 questions should be solved in 10 minutes, which will make 1 minute per questions. And if the student solves between 8 and 100% and submit the journals, then he will get exceed expectation. And then if he gets 100 and no journal submittal, he will also get exceed. 80 to less than 100 with no journals, he will receive meet. 70 or less than 80 and with the journal it will get meet. 40 or less than 80 no journals, it will give, whether it is with or without journal, it will get an I, and then NCE, NS. Now, if the student gets an NI, that means the student has to make more effort on the course, because this is a part of the active learning. So if the student gets an I, then he would receive like 2 weeks to make to correct the quiz. The correction will be done that he should receive the quiz feedback and correct the questions, and also submit a journal. Now, if the student received an NCE, then the quiz has to be rephrased, and also has to answer all the questions with rephrasing, and also has to submit a journal. The same goes with NS. So with the student is absent, he will get NS. And also one of the issues that we are focusing here is affective behavior. And here the student, if is absent, then he will also be affected with the measurement of the affective behavior, whether it is with excuse or without an excuse. So here again, students should also be or advised to be a good member within the team, and also a good member within the class. Okay, so when it comes to the implementation, so in 2019. So I moved the course into electronic version. So here I relied on the Blackboard. So the Blackboard, I have used the following tools: online quizzes using the test bank. So here I populated a test bank that contains over 200 quizzes. And then each time, for each student, he will randomly get quizzes from certain topics. And this will be done, the grading will be done automatically. Also, when it comes to creating groups, because this course is given for student in civil engineering, in mechanical engineering, and also in electrical engineering. So we have the 3 disciplines. It is multidisciplinary course. So here we are forcing students to gather in a very heterogeneous teams, and this is based on random enrollment. So here I'm using Blackboard for random enrollment. I use also from the Blackboard the self and peer assessment options. The assessment for journal submission and quiz makeup correction are also done through the Blackboard. And also whenever the student submit the work, this work has to be screened using plagiarism checker. This also to address the ethical issues. And for the student, they have to collaborate, whether inside or outside. And then they will use the Blackboard Collaborate to conduct meetings, especially that students are usually not from the same area. Now, for the 2019, so I have provided these problems. Students at the College of Engineering are finding difficulties in parking their cars. So this is a problem statement. And the students have to go through the 5 stages. So they have to go through the problem definitions, and here they also with this they have to come up with a solution. In the solution they need to at least to have a 3 competing solution, and then they will design the course of actions, implementation, and evaluation. Now with respect to the lab, so they have these 5 phases. So in problem definition, so they have to go through problem statement. They have to gather information about the problems, and then they will write the problem definition, and then they also have to evaluate the problem. The problem. So if the problem is ill-defined, then they have the chance here to correct the problems. In phase number 2, they will generate ideas. So here we are asking them to generate at least 10 ideas using multivating, generation of wants and must. So they need to have at least 5 must and 5 wants, and then they will also use the Osborne checklist. In the solution selection, they will create a KT decision analysis table. They will develop an adversary consequence table. They will estimate the cost, and then they will select the solution. In the implementation, they have to go through task prioritization, development of a Gantt chart, propose necessary materials, sketch drawing, and prototyping. And in the final stage, they have to do test impact on environment, culture, and society. So in 2019, so 4 teams. So in total, I had 20 students, because each team there are 5 members. So these 4 teams, they worked on the same projects, but with different perspective. So in team number 1, they come up with the parking which are organized by department, and then they have used the latest technology, Arduino, RFID, and IR sensor, infrared sensor. Team number 2, they approach the problem by counting the number of empty slots, and I have a video later on to show this. So they have used Arduino IR sensor plus also servo motors. Team number 3, they have worked with parking monitoring, and here they have used apps, smartphone apps, Arduino, and IR sensor. And the last team, they worked on the occupancy information, and they also worked with Arduino and IR sensor. So here is the video. This is for counting the number of the number of vehicles, and this is done at the celebration day. So here he's counting the number of empty slots. If the slots are full, then it will close. This barrier will close. Okay, so also we have done the assessment, because we are also requested to write a course report, and this is based on the direct assessment. So here we have So the students have evaluated based on over 24 questions, and we have from there taken 2 strength points and 2 weaknesses, and the weaknesses have to be addressed later on. So the strength is the instructor was fully committed to the delivery of the course, and the course helped me developing the team working skills. The weakness, the requirement for success in the course, including the assignment to be assessed and the assessment criteria were not clear to me, because students are not really familiar with such type of assessment using industrial standard. The amount of work in this course is not proportional to the number of credit hours allocated to this course, because this is like very, very demanding. And even we have reduced the load based on some automated way at the instructor side, but also the student felt that there are too many assignments for this project, for this work in this course, which is significantly larger than what the average course have in their curriculum. Okay, so as a conclusion, so the legacy teaching and learning methods need to be replaced with active and student engaging techniques that help foster critical thinking, problem solving, self-regulation, teamwork, and communication skills, which are really needed by the industry. And there is a strong need to engage companies in designing class activities through case studies and problem definition. And here CBL and the challenge-driven education can help with this issue. Thank you so much for your attention, and I look forward to your questions.